Hi everybody, this video we're going to go through properties of parallelograms. So first of all, parallelograms, if they don't draw the picture for you, I just need you to understand these points are called vertices. And so I would call this parallelogram ABCD, and you notice how the letters trace around the shape. So if you ever have to draw your own parallelogram, just make sure you pick a vertice, you pick a corner, and then label alphabetically all the way around. All right, so parallelograms obviously have opposite sides parallel, but the properties that we're going to need to actually use to set up equations are the ones that I've listed here. So in a parallelogram, opposite sides are congruent to each other. So that means AB is the same length as CD. And that little symbol means congruent. It means the same thing as equal. BC is the same as AD. And so the only reason that I use two little marks here is to show you that the ones that match are the same. So this side is not going to necessarily be the same as this side because the number of marks is different. All right, the opposite angles are congruent to each other. So that means angle A and angle C are the same. Those are opposite. It also means that angle B, actually I'm going to pick a different color. Angle B is the same as angle D. So I purposely picked two colors for that. So when they're the same color, they're equal to each other when they're in opposite sides. All right, consecutive angles are supplementary. So consecutive is like, just think about where you've heard that term in normal life. When things happen consecutively, they happen kind of back to back. So I kind of refer to these as back-to-back angles. And supplementary means that angle 1 plus angle 2 adds up to 180 degrees. So it's important, most of the time, it's easy to remember that supplementary goes with 180 degrees, but it's important that you remember you have to add two things together in order for them to equal 180. So in this example, any green paired with a blue are consecutive angles. So like angle B and angle A. And another way that I kind of like to use as a trick to help identify them is, it's not really great, but do you see how that kind of made the letter C for consecutive? That like bracket kind of shape. So those have to add up to 180. So in this example, A plus B have to add up to 180. B plus C has to add up to 180. C plus D has to add up to 180. But as soon as you find one of them, I mean, they're easy to find because the other side is the same. All right. And then diagonals bisect each other. So I haven't drawn the diagonals yet. Diagonals are line segments that connect opposite vertices. So if I draw a line from A to C, that would be a diagonal. If I draw a line from B to D, that is a diagonal. Bisect, basically it means to cut it in half. If you have two halves, those halves are equal to each other. So it also makes two equal pieces. But basically what that tells us is where they intersect, that M is the midpoint for both of those pieces. So basically the diagonal AC, half of it is from A to M, The other half of it is from M to C. So a lot of times we'll also put those little marks to show you that those two pieces are the same. And same thing, from M to B is the same as from M to D, and those two are half of the entire piece. All right, another thing that happens when you draw the diagonals is it makes more angles. You see how now angle A is in two pieces? Same with all of the others. So now I have more information about angles. I don't know if you remember back in the day, two parallel lines cut by a transversal. You would have done that back in like the 7th grade. So you're gonna have to think pretty far back. But basically, because a parallelogram has both pairs of opposite sides are parallel, I can also say, I'm just trying to find a different color. This will do. That basically the alternating pieces in opposite corners are equal to each other as well. So like this piece, that angle is equal to that angle. And I kind of recognize alternate interior angles by like a Z shape or an N shape. So those two angles are equal to each other because those are alternate interior. And so the other sides that I didn't fill in, like those two would have to be the same. And same thing for the opposite pieces for B and D. Like that piece there, that angle would equal that angle. And so same thing, the other parts that I didn't color in are equal to each other as well. All right, let me check that off in purple because that's where I drew the diagonals. All right, so for this example, we have a bunch of stuff to find. So let's look at the properties and see which property is going to help us find what. So let's start with X. X is an angle. I can tell by the degree symbol, and also it's on the inside, so that's usually a good clue as well. Well, I don't know what that angle is, so that's not really going to help me to find X, but I do know what this angle is. So I have to think about what is angle X in relation to that 100-degree angle. Is it opposite or is it consecutive? Since it's on the opposite side, X is opposite, and opposites are equal in parallelograms. All right, so Y is consecutive. Y is going to be consecutive to that angle because they are connected. They're back to back. They're on the same side of the parallelogram, so they have to add up to 180. So I know 100 plus Y has to add up to 180. So I purposely picked one that would be kind of easy math to do. So Y has to be 80 degrees. All right, W. W is on a side. So the only information I know about sides is that the opposite ones are equal. So W has to equal 12. All right, Z is also on a side. So my opposite sides have to be equal. So in order to find Z, I'm going to have to solve the equation 42 equals 10Z plus 2. So I'm going to have to solve that equation to figure out what Z equals. So I would subtract 2 and then divide both sides by 10. So I would wind up getting 4. All right, the next one, we have some diagonals here. So the thing I know about diagonals is that this is the midpoint. So that means this piece is equal to this piece. So that's how I'm going to figure out what X is. I know that the two pieces of the diagonal are equal to each other. So 3x minus 1 equals 2x plus 8. I'm going to have to solve this for x. So I will subtract 2x on both sides. I will add 1. So x is equal to 9. Pay very close attention to geometry problems, what the question is actually asking you for. So if I just asked you for x, we would be done. But if I asked you to figure out what BE was equal to, that means I want you to plug it back in. So 2 times 9 is 18. 18 plus 8, is that 26? So this should be 26 as well. And it is. 3 times 9 is 27. 27 minus 1 is 26. If I asked you to find from D to B, that's the whole entire diagonal. So both pieces are 26. So if I want to find the whole thing, I have to add them together. So 26 times 2, or 26 plus another 26, 52. All right, to find y, again, I have the other diagonal. So I know that these two pieces are equal to each other. The problem is I don't have any other information for what EC is. So I know from A to E is 5y plus 6. So I mean, technically, this is also 5y plus 6. But I can't solve an equation that says 5y plus 6 equals 5y plus 6. Obviously, it's the same thing. So look at what else they give me. I know the whole entire diagonal is 32. So if part of it is 5y plus 6, the other part of it is also 5y plus 6. When I put those two pieces together, that will give me from A all the way to C, which is 32. So that's how I have to set that up. And so you can either do it as 5y plus 6 plus the other side, or because it's the same, you could do 2. Technically, we have 2 5y plus 6s. When I put those together, they equal the whole thing. So that's 10y plus 12. So solve for y. So subtract 12. Divide by 10. We get y is equal to 2. The other thing that you could do for this is if you know from A to C is 32, then that means each of these is 16, because that's half of 32. So you could also solve 5y plus 6 equals 16, and it would give you the same thing. You would still get y is equal to 2. All right, so some takeaways. Always make sure you read the problem, and if they want you to solve for x, you're done. If they want you to find an angle or find a side, that means you have to plug something back in. And before you try to solve for x, really think about what you have. Do you have a diagonal? Do you have an angle? Do you have a side? And then use the properties to help you set up the equation.